Okay, so today we're going to go over inequalities. And the biggest thing with going over these inequalities is it's the same as equations, except with the inequality signs, there's just a couple other features that happen, and we're going to graph these at the end. So just like our equation video, we're going to start by distributing. So that is going to give us 167, which is less than 6, plus 14 minus 49r. From here, we can add those things together, so we'll get 167, which is less than 22, just 20, minus 49r. We'll then minus 20 from both sides, which is going to give us 147, which is less than negative 49r. And then we'll divide by negative 49, divide by negative 49, and that is going to give us that r is greater than, because we got to switch the sign around, so 147 divided by 49, negative 3. So negative 3 is greater than r. So what you want to make sure that you're doing with all these things is just make sure as you kind of go through, you solve it like normal, just like we've done with all the equations. But anytime we divide by a negative number, it ends up flipping the sign. Let's try another one. Okay, so for this problem, let's combine our like terms. So that's negative 6x minus 16, which is less than 2x. We want to move all the x's to the same side. So I'm going to subtract 2x, I'm going to subtract 2x. That's going to give me negative 8x. Minus 16 is less than or equal to 0. I'm going to add 16, I'll get negative 8x is less than 16. Then I'll divide by negative 8, divide by negative 8. I'll get x is greater than negative 2. And that would be my final answer. We're going to graph this real quick, just so we can kind of go through the graphing rules. So when you graph this, it falls somewhere here on the number line. We're going to use an open dot because it is not equal to, so we don't get to include negative 2, so we make an open dot. And since x is greater, we're going to go off to the right, or that greater than way. So just make sure, as we're kind of doing this problem, you want to make sure that you solve it like normal, and then for the graphing thing, if it's an open dot, it's not equal to. When it's equal to, it'd be a closed dot. So let's do another problem. Now we're going to do some compound inequalities. The nice thing about compound inequalities are they are literally the same as the normal inequalities, except we just have to solve two different equations. So I'm going to draw a line down the or, because we're just going to solve this left side and then solve this right side. So we can solve this left side by subtracting 12, then in getting 4n is greater than, that'd be 32. Then divide by 4, n is greater than 8. For this other side, we'd do the same thing. We'd solve. I'm going to subtract 10 on both sides. I'll get negative 12 is greater than negative 48. Then we'll divide by negative 12. Whoops, I forgot my n here. We'll divide by negative 12, divide by negative 12. I'm going to get n is less than 4. And the reason that happened was because we divided by a negative, so it flips the sign. What we'll do now is we will just graph it, and you just graph the two parts. So that's where 8 is, that's where 4 is. They're both open circles because they're not equal to. 8 is greater, 4 is less. Okay. So it graphs pretty easily. Just make sure when you're graphing, you just read the two things, and all we do is graph them on the same line. Let's do the next. This right here is an and statement. It means you want both to be true. So right now this is saying I'm bigger than negative 33, but less than 26, or negative 26. So we're kind of bound in between this line. When we solve it, you'll kind of see how this works out. But what I want to do is get n by itself. So I'm going to add 12. Now when you add 12, because it's bound in between these two things, whoops, if I can figure out the other way with the reflecting camera back, because it's bound in between these two things, what we need to do is when we add it to this side, we also have to add it to the far side. So when you add, now it doesn't just affect one thing because you really have two equations here, so we add it to both sides. So that's going to give me negative 11 is less than or equal to negative 7n, which is less than negative 14. And now what we would do is we divide by negative 7. But instead of that just affecting one thing, again, that's going to affect both sides. Whoops, that was 21. Sorry about that. My math there was bad. It happens sometimes. But that's going to work out a little bit better. Okay, so then when we divide that, this is going to become 3. This is going to become 2. The signs are going to flip because we divided by a negative. So we flip the signs. And then when we graph this, we kind of graph it the same way we did before. So there's 2 and there's 3. At 2, we would have an open dot, and it's greater than, so it's going this way. At 3, we would have a closed dot, and it's going this way. And you can see how it's like bound in between those two things, like it's bouncing in between those two. So just make sure when you're graphing these statements, these ones should like make a line kind of like that in between, and that's how we would get our answer right there. The last thing we're going to talk about in this video is set notation. And set notation is just a different way of writing some of these things. And I actually like it a little bit more than our normal notation. Okay, so here's how set notation works. Let's say we got an answer to our problem, and our answer is 4 is greater, well, yeah, 4 is greater than x, which is greater than negative 3. Well, we know what the graph of this thing would look like. The graph of this thing would be 3, and then 4, solid dot, because it's equal to open dot right here, and it'd be something like that. And this is a lot of writing. So there's a faster way of writing this. We say this goes from 3 to 4, so we write it kind of like an ordered pair, and then we make a decision whether it's we have to make a decision whether it's a closed dot or an open dot. So an open dot is a parenthesis, a closed dot is a bracket. So in a problem like this, we would go from 3 to 4, and we'd have a closed dot at 3 and an open dot at 4. Let's do another one. Okay, so the set notation for this thing, this goes from 2 to 8. This is this closed dot, so we would have a bracket, and this is a closed dot, so we'd have a bracket. So that would be our set notation. We go from 2 to 8, and these are both closed dots, denoted by the bracket. Let's try another one. Okay, so this one, we only have one number, so 3. We're missing the number over here, which like is our bigger number. So we're going to say we go from 3, and the nice part about this is it's saying x is bigger than 3. And so we have to think, what is our biggest number? Well, our biggest possible number is infinity. So we're going from 3, and then since it doesn't give us a bound, we keep going forever and ever and ever and ever. Now this is a closed bracket because we have a closed dot, and this is going to be an open bracket. And you might go, well, why did we decide an open bracket for infinity? Well, the answer for that is we only use a closed dot when you like reach that point. Like we're saying we actually have 3. Like that is our point. But you can never reach infinity. So infinities are always open brackets. Okay? We're going to try 2 more quick ones. Okay, so 2 is greater than x. This one would be 2 comma infinity because we're not stopping. We're going to do an open bracket at 2 because it's not equal to. We're going to do an open bracket at infinity. This one is saying 3 is greater than x. So our biggest number is 3, and our smallest number is going to be negative infinity. And the reason it's going to be negative infinity is use negative infinity to show that we keep going towards the left side or towards the negative side. So that's what we have right there. From here, we would do an open bracket at negative infinity because we don't have it. And we do an open bracket at 3. So trying the different problems today. If you get stuck with anything, just let me know.